In this video, we will learn a machine learning method called support vector machine, which is used for classification. SVM is a supervised algorithm that classifies cases by finding a separator. SVM works by first mapping data to a high-dimensional feature space so that data points can be categorized, even when the data are not otherwise linearly separable. Then, a separator is estimated for the data that should be transformed in such a way that a separator can be drawn as a hyperclient. For example, consider this figure, which shows a small set of cells only based on the unit size and clump thickness. As you can see, the data points fall into two different categories. It represents a linearly non-separable dataset. The dataset can be separated by a curve and not by a straight line, which is the case for most of the real-world datasets. Now, we can transfer this data into higher dimensional space. For example, mapping it into three-dimensional spaces. After the transformation, the boundaries between two categories can be defined by an hyperplane. As we are now in this three-dimensional space, the separator is known as a plane. This plane can be used to classify new or unknown cases. Therefore, the SVM algorithm outputs an optimal hyperplane that categorizes new examples. Now, we will look into what are some of the advantages and disadvantages of SVMs. The two main advantages of support vector machines are that they are accurate in high-dimensional spaces and they use a subset of training points in the decision function called support vectors. So, it is also memory efficient. The disadvantages of support vector machines include the fact that the algorithm is prone for overfitting. The number of features is higher than the number of samples. Also, SVMs do not provide probability estimates which are desirable in most classification problems. And finally, SVMs are not very efficient computationally if your dataset is very big. And now, our final question is, in which situation should we use SVMs? SVM is good for image analysis, tasks such as image classification and handwritten digit recognition. Also, SVM is very efficient in text mining tasks, particularly due to its effectiveness in dealing with high-dimensional data. For example, it is used for detecting spam, text category assignment, and sentiment analysis. And another application for SVM is in gene expression data classification. Again, because of its power in high-dimensional data classification. SVM can be used for other types of machine learning problems such as regression, outlier detection, and clustering. I will leave it to you to explore more about SVMs. Thank you for watching.